short session, but I wanted to introduce Daniel actually as one of my personal friends as well. I think we've known each other for almost a decade now.
Many a year, Simon, isn't it? Yeah.
So yeah, Daniel works as an independent technical consultant and product architect at Data One. Yeah, Daniel's a really amazing community person as well, helping with the LJC, helping with a bunch of other kind of cloud native communities and things like that as well. So yeah, without further ado, I'm gonna pass straight over to you so you have the maximum time, Daniel.
Cheers. I'm going to share my screen. I think just add that to stream. We are all set. And if I press play, we should be good to go. Yeah. So welcome everyone to the past, present, and future of cloud native API gateways. So this is going to be quite a whistle-stop tour and quite sort of the overview slides, because with 25 minutes, and I think that's probably the best focus. The TLDR, like if you don't want to pay attention to the whole 25 minutes, the key TLDRs are that API gateways, edge gateways have undergone a series of evolutions, and primarily this has been driven by architecture up to this point. Adopting things like microservices and Kubernetes, yeah, that changes the architecture for sure, but also the workflow as well. And this actually has a big impact on how you work with API gateways. One key message I want folks to take away is choosing your cloud API gateway should be done intentionally. I think if you're going to Kubernetes, you're going to the cloud, one of the biggest mistakes I see in a general sort of theme is folks don't make intentional choices around their platform. Kubernetes is a fantastic bit of kit, but it's really a foundation for building a platform on top. There's many kind of parts of that platform, but the API gateway, how you get traffic in, is a super important part. So that's kind of my pitch today for the next 20 or so minutes. And this is me, as I mentioned, definitely Java is my native language. At Daniel Bryant UK on the interwebs, on Twitter, GitHub, etc. I do work as a product architect at DataWire now. You can find me on InfoQ writing as well. And I've written a book recently, my buddy, Abraham Rimprez, also from the London Java community, as Simon mentioned. And you can grab that book as well if you want to know more of my thoughts and Abraham's thoughts around continuous delivery as well. I'm going to mention the word edge a bunch of times, and it is an overloaded term, like edge computing, like IoT, data center, these kind of things. When I mention edge for the next 20 minutes or so, it's really about the boundary between your users and your data center. So it's the point, kind of the connection point between when users are coming into your system, they're accessing your backend services, accessing the functionality you're providing as an organization. It may be paid for, it may be not, but the edge is a super important part where your users and the bad actors first interact with your system. Now, the first thesis I want to mention is that I think the evolution of the edge up to this point has been driven primarily by application architecture. And I started my career late 90s, kind of just before I went to university, and Java was the thing. I learned Java, Java EE, EJBs became a thing for the good or bad around 97. And this is kind of the architecture we were building, and we put hardware load balancers in front of this stuff. We did all our application logic in EJBs and Java, but the hardware load balancer was controlled by the system admins, and their primary responsibility was making sure our apps were highly scalable and they were available too. And there might be some load balancing going on as we're, multiple instances at the back end. Going say 2000s, like racking and stacking was becoming a lot more popular in like commodity hardware. Google was sort of talking about this kind of thing. Many of us were still building Java apps, .NET apps, Ruby became a thing, and Rails around 2003, I think, but it was primarily monolithic apps. The interesting thing in terms of the API gateway space or the edge space was that things moved to software. nginx blazed the trail, HA proxy blazed the trail, the Apache web server was a big deal as well. This was pretty much the same as the hardware load balancer. The sysadmins controlled it. It was all about availability, all about scalability. And really, we were just swapping hardware for software, which was more malleable, cheaper. We could run it on commodity hardware. 2005, this is when I left uni. It's kind of when I went into the real working world. This was all about Web 2.0. This really was a thing back in the day, like as crazy as it might seem now. It was all about e-commerce, Amazon kicking off and a bunch of other interesting companies doing interesting things. And the big driver around dynamic websites was AJAX, this thing called AJAX. And before, we used to do request response. User make a request, we'd send all the HTML back to the browser. They make another request, we send all the HTML back. The thing that AJAX gave us was the XML HTTP request object, or more correctly, the XML HTTP request object gave us AJAX. And this allowed us to dynamically load bits of the web page. It's the precursor to things like single page applications. And this fundamentally changed the way clients were interacting with the back end. No longer was it request, big response. It could be, initially a big request response, but then lots of little responses as we've dynamically updated the page. This led to something called application delivery controllers at the edge, coined by, I think it was the F5 team, Cisco, Citrix, all those good folks. This was primarily aimed at system administrators, but it was more about application acceleration. So we're trying to do like SSL, TLS offload. We're maybe doing some caching. Like Varnish was super popular back in the companies I was working with, doing some compression, some zipping, some load balancing as well. But this is all about making these little interactions as fast as possible. It moved again from hardware to software, and there's still a mix in play now. Like F5 do some fantastic big IP stuff. nginx do a lot of stuff around this with software-based ADCs as well, and there's many other companies. I'm just picking on a couple here. If we sort of move into the I generation, 2010s, this is when the proliferation of APIs kicked off. So I was doing a whole bunch of work around Google Maps at the time, using their API, Stripe for payments, SendGrid for emails, this kind of stuff. And this is when we saw the rise of the first generation API gateways. Things like Kong were kind of pitching around this time. Not only were they aimed at system administrators, but also at API developers. It was about creating an ecosystem, potentially even monetizing your APIs. You're managing the APIs. We're moving less perhaps from, or as much maybe with layer 4 TCP kind of control, but also to layer 7, like HTTP control. We were looking at metadata in the HTTP headers. We're adding auth perhaps in the HTTP headers. There's this move from layer 4 to layer 7. And the developers, we were more in the mix now. We had an equal stake in this gateway as much as the sysadmins did as well. Think about 2015, like 5 or so years ago, the rise of all the unicorns and so forth. They were struggling, famously led to the monolith being decomposed into like smaller services. There was SOA going on in the background in enterprises anyway, but this is kind of like hipster SOA. We still need the ADC in front of it. We still needed to do caching, TLS offload, that kind of thing, but we were breaking up the monolith. And this then led to the monolith being sort of a central routing place or central routing place. So some folks started pulling out that functionality into a core API gateway. So we had the ADC up front doing TLS offload, caching, a bunch of other stuff. We had an API gateway maybe managing, things like authentication, a lot of cross-cutting concerns like rate limiting are being pulled up into the gateway. And then the monolith, the mini-lith is just another service that we're routing through. The API gateway kind of provides a nice interface. If you haven't read Chris Richardson's book, it's a really good book on microservices. He talks a lot about the API gateway pattern. Christian Poster, fantastic work in this space too. It's about that common interface of, developers interacting with the back end. Again, targeted at sysadmins and API developers, centralizing the cross-cutting concerns, and we're doing all these things like I mentioned, like the rate limiting, monitoring, routing. We as developers need to control this, but we need to sync up what we're doing in the applications into the gateways now, which is an interesting challenge. If we move into cloud native apps, this is all about microservices, the next generation of modularization. Think about David Parnas, 1970s, probably even before that as well. Modularization was a thing. We don't always learn our lessons in IT. We keep reinventing the wheel. Microservices is kind of the latest evolution of that. It's all about scaling the development efforts, independent releasing of functionality, and scaling components independently. This has kind of led to many technologies rising up to support this. Microservices as an architecture, Docker, containers, Kubernetes, all these good things that support our deployment of these services. It now means that this API gateway has to route to many different locations. VMs in the cloud, VMs on-prem, Kubernetes, there's functions as a service, multiple protocols, different load balancing requirements, different auth requirements, different kind of cross-functional concerns and requirements. This is leading to a new kind of definition of an API gateway in my mind, and the team at DataWire, we're talking about this quite a lot. Cloud API gateways need the API gateway management capabilities, authentication, dev portal, top-line metrics, 503s, latency, all that kind of thing. It needs the ADC-like functionality, so cross-functional requirements, timeouts, retries, rate limiting. But you also need now to think about real-time service discovery. Kubernetes, keeps your service running, but the location may disappear and come back at different places in the cluster. VMs kind of similar. Functions are ephemeral by nature, scale to 0, scale up, and so forth. This is these are the 3 key capabilities you need in a cloud API gateway these days. So this is really, now when we as engineers are interacting with this edge, interacting with the API gateway, we're often combining all the things I've talked about. ADC, load balancers, API management, service discovery. It's quite a lot to think about, to be honest. And we as full stack engineers, this is another thing perhaps to think about. But microservices really lead to this even bigger change. And this is the notion of dev on call, or you build it, you run it. It's a bunch of names. We as engineers now are being forced to take more responsibility. We have the ideas, we work closely with folks who have ideas, we code, we test, we deploy, we release, we look at the metrics, and then we iterate as fast as we can. Yeah. This is Netflix folks are calling this full cycle development. It's not full stack, full cycle, is in that engineers are taking increasing responsibility, but we are relying heavily on the platform folks, on the SRE teams. The platform folks are building out these awesome platforms. They're giving APIs, SDKs we can interact with. We can also, it's all about self-service. We can use their tools. They may provide us tools. You may be having an in-house platform team, or you may be outsourcing it to Amazon and relying on their UI, their API, their tooling. But we as developers now are quite often responsible from idea to code to release and iterating back. This really, in my mind, is very much a change in workflow. Yeah. So I think really the thesis we had up front about the evolution of the edge being driven by application architecture is probably still valid, but also we need to think about the application developer workflow now. Yeah. And this really, my work at DataWire, I've seen this a lot, and I definitely saw this when I was consulting too. There's the 2 biggest challenges I see when you're moving to the cloud, moving to things like Kubernetes in relation to the edge. One is scaling the management of the edge. Yeah. When I was a developer, I'm building my monolith or whatever. It's nice and easy. I had libraries to do caching, libraries to do, expose REST APIs or whatever. And the platform folks looked after the API gateway for me on my team. If I wanted to modify the API gateway, say to open a port or new protocol support, I typically raise a ticket. The ops team would do some good work. They may ask some questions, and it goes around. Raising tickets is never super efficient. We as developers, we want to go super fast. Now we can't if we're doing this it worked in the monolith days. It doesn't really work in this cloud native days. We're pulling more and more stuff up from the monolith now, because there's many services. We're pulling it up into the API gateway. The API gateway does auth, does retries, does caching, and there's many services now. We can't possibly be raising tickets for all this stuff. Yeah, it simply won't scale. I need to, expose a new protocol, I have to raise a ticket, or I want to put some caching onto my my service, I have to raise a ticket. We're trying to go fast. This full cycle ownership thing, it just doesn't work. The second big challenge we see is supporting diverse edge requirements. So we all love our REST, of course, our JSON over HTTP, but we're bringing in things like gRPC. We're bringing in things like WebSockets for streaming. And again, these have subtly different ways of doing auth, perhaps doing caching, these kind of things. And I might also want to mix and match my cross-functional requirements. Some services want auth, some may not. Some may want retries, some may not. One service I might want to bring caching in. And again, if I'm raising all these tickets and we're trying to support all these different things, it's really quite challenging. We need the gateway to support these things and allow us to compose and sort of modularize our protocols and our cross-functional requirements. Now, I see 3 strategies out in the wild. Folks, they're moving to Kubernetes. They've probably got an existing stack, an existing API gateway maybe. And as they're moving to Kubernetes, they broadly fall into these 3 categories. Folks either deploy an additional Kubernetes-based API gateway and link that up to their current one. They extend the current gateway into the Kubernetes cluster, or they go all in on the cluster, and the cluster maybe new stack goes in there for managing the edge, managing APIs, and any of the sort of vintage systems, the core systems that are still around, they route from Kubernetes out to these older world systems, the money-making systems. I'm sure there is other sort of strategies around there, and I'm not going to argue these are necessarily best or worst here. I've got my bias working at DataWire. We're in very much with Ambassador. We're looking at strategy 3, but I've seen combinations work of all different technologies and all different strategies here. So I'll run through in the next 10 or 5 minutes or so. I'll just give you a whistle-stop tour. I've written about this on the website, so you can pop along and if you want to know more about the strategies, the challenges, how you implement it, these kind of things. The first one I want to talk about is deploying an additional Kubernetes API gateway. So this is like folks, they spin up a Kubernetes cluster, they deploy an API gateway into it, or an ingress, for example, or a service load balancer, and they basically pass through certain routes or certain endpoints from their existing API gateway into the cluster. So like /new world goes through into the Kubernetes API gateway, /old world would go into the old gateway. Some folks split at the API gateway layer. Some folks split at the kind of layer 4 layer. So they say this IP goes to here, or this domain name goes to here, this domain name goes to here. But it's fundamentally about spinning up a new API gateway within Kubernetes. The pros are that it's very easy to get started. You can spin up a kind of like team that just looks after the Kubernetes cluster, deploys an API gateway, and kind of mashes it up with the existing one. Incremental migration, super easy in this use case too. The challenges are working with two gateways. You've now got one gateway doing a pass-through potentially. There might be different like subtle nuances I've seen, like one gateway strips headers, the other one doesn't. I've had some crazy bugs dealing with these kind of things. And you are fundamentally working with two gateways. Easy to get started, operationally a bit challenging as time progresses. The second strategy is around extending the existing API gateway. So this is about taking your existing gateway, maybe put some plugins in, some scripts, and that will then synchronize the location of your services in Kubernetes, like with an IP address, into routes and endpoints into the API gateway. So you're not necessarily like have a second API gateway in the Kubernetes cluster, but you're kind of bypassing that, or you're routing directly from the API gateway you've got now into the Kubernetes cluster. Often you do this by having some kind of controller in there. So I've seen some like the F5 team, for example, they have this controller that sits in your Kubernetes cluster. It watches the API of Kubernetes. When you make a new deployment of a service and put some annotations on that service, the controller watches what's going on, says, new service deployed, new annotation, says they want to expose this endpoint here. And then the controller makes the out-of-band requests to your API gateway, maybe a hardware gateway, via the control plane for that gateway. It may call some SDKs, call some APIs, but we don't really care about that. We define our world in Kubernetes, and the controller is synchronizing with the existing API gateway. Now, the pros, again, super easy to get started, yeah? And you can also leverage all your existing kind of kit in this world. The challenges I found is the split between the old world and the new world. You often have to do sort of one workflow for deploying into Kubernetes. So I write my service, write my YAML, put some annotations on it, and that then deploys and exposes my service. But if I'm modifying the old world, the core and the vintage world, completely different workflow, because YAML is not recognized in the old world. And that it's sort of having this notion of single source of truth gets a bit tricky. Like what happens if you get a clashing route? Who wins in this kind of thing? Like, does the new world win? Does the old world win? And I've struggled as well with the annotations available on some of the controllers. So you can't always do everything as a developer from a self-service perspective. The annotations, like the full functionality of the existing API gateway, can't be controlled with all the all the annotations. So you often have to go out of band anyway, raise a ticket with the ops team, they modify the API gateway, and so forth. Again, super easy to get started. You're leveraging all your existing investments. So this is quite a popular strategy, to be honest. And you do sort of bypass some of the Kubernetes networking challenges, dealing with ingress and things. But I've just found this kind of single source of truth can cause a bit of friction going forward. The third strategy is deploying an in-cluster edge stack. So this is using sort of more modern kind of technology. You see Envoy pop up a lot here, but of course nginx and AJ proxy and Trafic have a sort of a horse in this race too. But this is about putting your entire edge stack. So typically there's a WAF involved, layer 4 load balancer, API gateway, dev portal. You're putting this all in the Kubernetes cluster. And therefore, you get the benefits of you can configure it like any other Kubernetes service. Everything's done via YAML. You have controllers, sort of, looking at what's going on and making changes and so forth. This is kind of, if you're greenfield, this is probably what you're going to do because you've got no existing investment in an API gateway. But if you're in the old world, if you have core systems, vintage systems, this is a big stretch to do off the bat. Often folks do strategy 2 with a goal to get to strategy 3 eventually, to get rid of their old world as they move to the new world. Everything is running in the cluster here, as you can see in the diagram here. The pros is, it's super simple. Once you get it up and running, there's a single stack, single source of truth for your config, and you can do things like GitOps. I haven't got time to go into GitOps here today, but it's sort of emerging as a best practice in the Kubernetes world. We define all our operational all our configuration using Git, and then we sort of drive the deployment of this via a Git repo. The Weaveworks team, Alexis and company, have done fantastic work in this space. If you want to know more about GitOps, definitely pop over to their website. But these are good practices that are hard to do with the other strategies. This notion of a single source of truth in Kubernetes YAML or custom resource definitions. The cons are obvious. Yeah, it's potentially a large architectural shift. We've got a lot of investment in our existing stack. For example, the platform team are going to have to learn all new technologies. Like Envoy is very different from hardware load balancers. There's lots of new things to learn. This can be quite scary for folks to make sort of the full leap into this new world. So that was a bit of a whistle-stop tour. I wanted to really get you thinking today about these things. Like, the key message really is the future is definitely pointing towards things like software. It's pointing towards things like sort of smaller services, functions, these things. You need to be really intentional about how you build your platform. I see many folks kind of just fall into a platform. Almost like the joke is kind of you're building a platform one sprint at a time. We put a bash script on here. We put a bit of Kubernetes YAML on here. Before you know it, you've got this horrible monster of a platform sitting on top of Kubernetes. Yeah, and like thinking there's many things within a Kubernetes platform, but the edge is really important. How you get traffic from your users into the back end is super important. So the conclusion I'm going to leave you with is there's this definite move from hardware to software. Yeah, software is more malleable, tends to be cheaper, easier to scale, these kind of things. There's a move, like with the rise of Envoy as a very popular proxy, but all the other proxies are kind of catching up now. But there's a move from this layer 4, like a TCP level, to layer 7. So a lot of the API gateways now, a lot of the proxies are application layer aware. They understand HTTP metadata headers. They understand Kafka headers. They understand RabbitMQ, AMQP headers. And they can do intelligent things based on that layer 7 data. They're not just making decisions based on layer 4, on IP addresses and ports and things. They're making decisions based on layer 7. There's a move from like centralized management to decentralized. I, as a developer, want to go as fast as possible. The platform needs to be self-service. I need to be able to open ports. I need to be able to put new protocols in. I need to be able to mix and match my cross-functional requirements. Adopting Kubernetes and microservices clearly changes the architecture, but it changes the workflow. The biggest change for me, with adopting like doing Java and Kubernetes and stuff, it's just a different workflow. I'm now responsible for building a container. I'm responsible for deploying that container. I'm responsible for releasing that functionality via the edge. And I have to scale the edge management. We can't all crowd around one edge config file anymore. And I also want to be able to mix and match my cross-functional requirements, bit of rate limiting here, bit of auth here, different caching over here, and I want to support multiple protocols, because I may even be exposing like Kafka at the edge, say, because I've got like an IoT device that's talking to a Kafka cluster. The really one key message, I focus on the API, I focus on the edge. That's what I'm doing these days and what I enjoy. But a key message is if you are moving to the cloud, moving to things like Kubernetes, choose your solutions intentionally. I've made this mistake. I'll put my hand up and say, a few years ago, I was working on Mesos, pre-Kubernetes, did a bit of Kubernetes as well at that time. And we were not making all the right decisions up front. You don't want to make every decision up front, but we weren't being intentional with the design of our platform. So the key message really today is if you're moving to this new world, you may have an investment in the old world, just think about your end goal. Think about the journey from A to B. When you really need to invest in your platform as a product, or maybe you want to buy a platform, that's totally cool too. But really do think about the platform. And I say, my bias is to start at the edge, because that is where the traffic is going to be coming in. That's where your users first interact with the systems. So whistle stop tour. If you want to learn more, pop along to the getambassador.io website. I've got like nice, Kelsey and the team put together a nice landing page there. If you want to learn more about Kubernetes platforms, we've linked off to a bunch of other interesting folks as well. I'm doing a bunch of podcasts with DataWire, so hit me up if you want to jump on the podcast at some time. Chatted to Matt Klein last week, Paris, and a bunch of other interesting folks. Of course, I'm always on the blog on Get Ambassador too. Find me in the All the Talk Slack. I'll be track hosting for the next couple hours too. Hit me up on GitHub or Twitter at Daniel Bryant UK. But at that point, I'll hand back to you, Simon, if you're still there, and we can take questions.
Awesome. Thank you very much, Daniel. And let's, in fact, what I'm going to do, I'm going to pull our next speaker in as well. Why not? Let's do this.
Hey, Sebastian.
That's in as well. Okay. So, I have a couple of questions. One was about a couple of resources that you mentioned before regarding microservices. So one was a book by Chris Richardson.
Yes.
Remember the other was a Sam Newman one?
I mean, I'm loving to. I've got Sam Newman's actually over here. I can definitely dump any links, Simon, into like the Slack later on. I'll look through the presentation and see. But yeah, definitely Chris Richardson. Sam Newman's book's fantastic. Off the top of my head. Oh, I mentioned Christian Poster as well. Christian's like got some fantastic blog posts.
Awesome, thank you. Yeah, and the links will be cool in the Slack afterwards. One question, Justin: if you're a complete beginner with regards to Kubernetes, where is a good place to start? Assuming understanding the fundamentals of networking and things like that exists already.
Yeah, it's a great question. It's one I get a lot. And let's be honest, like containers and Kubernetes are not simple. I forget this sometimes. I'm steeped in it day in, day out. I think the Kubernetes docs are very good. And there's also a blog, also a nice O'Reilly book by, I might get this wrong, but I think it's Kelsey Hightower, Brendan Burns, and Joe Bader. That is a really nice resource. If you've got like, if you like paper books, or if you want to jump on like what was Safari, I've learned a lot from Kelsey, Joe, and the team over the years, and Brendan. And that's often my starting point. Grab the O'Reilly book, have a look through. It'll give you a good jumping off point to learn all the other things I mentioned.